So in this brief lesson, we're going to investigate parametric equations and specifically understanding collisions of objects using the graphics calculator TI-84+. So the scenario we're going to investigate is below. So P and Q are particles with displacements in meters at time t seconds, given by that equation and that equation. And the question is, if these particles collide, determine when and where they collide. So firstly, there are two objects that we're interested in, object P and object Q, and those are the displacement vectors for each of those. We're going to just take a little bit of a closer look at object P to understand what that's telling us. So the first part, the displacement R, so we use the vector R, of object P from the origin at any time t. And you can see that the displacement in the x direction is a function of t, so the x direction parallel to the I vector, and the displacement in the y direction, or parallel to the j vector, is also a function of t. So you can solve these equations or solve this problem algebraically. That's one process, but we're just going to look at how we would investigate this problem using our graphical calculator. So the first thing that has to be done in order to investigate where these points will collide using your graphics calculator is to ensure you're in the correct mode. So if we go to mode, typically you'll have your calculator set in function mode, but we want it in parametric mode. So I've already set mine to parametric. And then when to input our two parametric equations, we go to y equals, as we typically would, and we input, you can see here we have x1 and y1 as functions of t, and then we have our second object, which is x2, the positions x2, y2, and they are as functions of t as well. Now I've already put those functions in, and you just put them in the same as you would put in a regular function. You can see here on this button there's an x, which is typically what we're referring to, but in this case we're putting them in as a function of t. And you can also obviously put in as functions of theta, etc. So those functions are in. I've got my I component of object 1 and my j component of object 1, I component of object 2, j component of object 2 input already. Next, we need to graph them. Now, setting the window for parametric equations is in some ways the most complicated bit. I've already set this window appropriately, but you need to think about what are my x and y coordinates for each object when t equals 0, and what do I need t to go up to in order to capture the collision point or points. The other thing is, make sure that your increment of time is quite small, otherwise you won't get a smooth curve. So if you go from t equals 0 to 10, for example, and go up in ones, you will only end up with 10 points for each curve. So going up in point ones makes it specific or smooth enough. And then I have my constraints for x and for y. So I need x to go, in this case, x go from 0 to 10 up in increments of 1, and y going from 0 to 5 in increments of 1. And then I graph it. So I now have two curves, and you can see here on the table, which I've listed, I've got my particle 1 is in blue and particle 2 is in red. Now, in order to find the collision point, I go to trace, and this is where it gets very interesting. I can trace along this curve, and notice what happens to time. It's going to go up in increments of 0.1, because that's what I set my time to go up by. So after 3.7 seconds, object 1 is at the point 5.7, 2.197. As I scroll along the curve, after 3.8 seconds, it's at that point, 3.9 seconds, and after 4 seconds, it looks like it intersects with the other curve or the other object, so after t equals 4 seconds. Now I'm going to shift curves by going up or down, and now I've moved to my red curve, and notice what happens when I increase the time. That object is actually moving in that direction as time passes. So as time increases, this is the new position of the object. Now if I go back through time, 4.5 seconds, it's moving in that direction, and 4.1, 4 seconds, it looks like it's at the same point. In fact, it is at 6.1. So I have a collision after 4 seconds at the point 6.1. So this is why parametric equations and collisions are slightly more complicated than typical functions. Normally, when you are going to find the intersection points of two functions, you just do simultaneous equations and find that they cross at that point. But for a collision to occur, not only do they have to be at the same point, but they must be at the same point at the same time. So just bear that in mind when you're performing your calculations.